Hello, good day. Here in this virtual class, I'm going to take you through some principle on divisibility rules for prime numbers. You know, sometimes we want to check if a number is divisible by another number. So there are ways or method of handling this. So a divisibility rule is a useful and a shorthand for knowing if an integer is divisible by a fixed divisor without necessarily performing the division operation. So in this class, we are going to look at that. How do we generate numbers that we can use to test for divisibility of numbers, especially prime numbers. So in this class, we're going to look at prime numbers such as 3, 7, and 11. Okay. Now for 2 and 5, the rules are very quite obvious. So we will not be looking at 2 and 5, but 3, 7, and 11 in this class. So in our next class, we are going to look at other prime numbers. Okay, and the principle here we're going to use is what we call the seed numbers. The principle here is, state that every odd prime numbers usually give a unit digit of either 1 or 9 in their first two 10 multiples multiples. Okay, what it simply means here is that there are some prime number when you multiply them, their unit digit will either end in 1 or 9, so that will be our basis for formulating the seed numbers. Okay, now let's go into operation, starting with 3 as a prime number. Okay, now if we're having 3 as a prime number, we look for another number that can multiply 3 so that the unit digit can become 9 or 1. So here we can say 3 times 3, 9. It's a single digit number, 9. So that is the unit digits. Okay, so here what we usually do here, for us to formulate our 10 multiples from this 9, 9 is the same thing as we are saying 10 minus 1. Alright, here this 10 we can also say is 1 times 10 minus 1, and this one will also give us 9. So we replace it here, we say this is 1 times 10 minus 1. Okay, and this is what we're trying to say, that in the first 10 two multiples are two odd numbers. So the product of some odd number will usually end with either 9 on this, so we use it to generate this. Here, this one here is what we are looking for, is what we call the seed number, and we have to look at this. This is minus 1. Anytime that we express this, it will usually end in either 1 or either plus 1 or minus 1. If we end with minus 1, our seed number will come just be what? Positive 1. Okay? Now let's look for another number that will multiply so that by 3, so that the unit digit will come 1. Okay, that is 7. 3 times 7 give us 21. So our 21 is 20 plus 1. And we can also express this as 2 times 10 plus 1. So we replace 21 with this expression. So this becomes 2 times 1 times 10 plus 1. 2 times 10 plus 1. Here, this is our seed number, which is 2. But because this one is plus, like I said, your seed number will become minus 2. Let's look at this. Let's check if what we're saying is true. We want to test if 3 is divisible by Let's think of this number 126. Let's see. Yes, 3 can divide it. Let's test whether if it is possible that 3 can divide this. What we usually do, we use this seed number to multiply the unit digits and add it to the remaining digits. Here we are saying 6 times 1. Okay, 6 added to this will give us 18. If I'm not too sure, again, you can see multiply it by the seed number 1 times 8. It's 8 added to this 9. You see that it's divisible. Then even if we want to do it for test it with this minus 2, this was minus 2 times 6. It's minus 12. You add it to this will give us 0. So that is one way of testing for divisibility rule. Now let's look at another prime number. The next prime number is that we're going to look at is 7. Okay, for 7 here, it is already derived here. For 7, so we're having 7 times 3, 7 times 3, which is 21, which is the same thing as 2 times 10 plus 1. And quickly, our seed number there is minus 2. Okay, now let's look at when the unit digit will end with 7. 7 times what? So that the unit digit will end with 7. That is 7. So that will give us 49. And you know 49 is like 50 minus 1. Okay? So we can express it as 50 minus 1. This is 5 times 10 minus 1. So we replace this as 5 times 10 minus 1. Our seed number is it because this one is ended with minus 1. The seed number will just be plus 5. Okay, so that is for 7. So the two seed number for 7 are minus 2 and 5. Okay, so if we want to test for, assuming we have 49, we want to test whether if it is divisible by this. So we'll say minus 2 times 9 minus 18. Minus 18 plus 4 is minus 14. So it's divisible by 7. So 5 here, this 5 times 6 is 45 plus 4, 49. Okay, it's also divisible by that. Okay, now let's look at the last one here. We're going to look at 11. So 11 times 4 will give us, so that the unit digit will become 1. It's 1. 11 times 1. So it will give us 11. And 11 is 1 times 10 plus 1. So here we have 1 times 10 plus 1. Because of the fact that this is plus, our seed number will become minus 1. Okay? Then another way that we can also obtain this, the seed number when the unit digits will end with 9 is 11 times 9. That will give us 99. And our 99 is 100 minus 1, which is 10 times 10 minus 1. So here we have a 10 times 10 minus 1. Because of the fact that this one is this is minus, our seed number here will become 10. So now let's test for it. I think we will have a 121, which is divisible by 11. We want to test now. Here minus 1 times 1 is minus 1. Added to this we have 11. Here 10 times 1 is 10. Added to 12 we have 22. So this is how we generate it, the seed number. The essence is that sometimes you want to know if a number is divisible by another number. So this text is quite expedient, you know, when you want to know whether if an integer is divisible by a fixed divisor. Okay, please help me subscribe when you see this video, and also help me share to other platforms. See you in our next class. Have a nice time.